Welcome to Solidcam Professor. I'm Sydney, your Solidcam Professor, with one of many recordings available to you 24 hours a day, 7 days a week. In this session, we'll be showing you our new option of parallel computing. Now, what parallel computing does, it allows the user to start a calculation of an operation or several operations while it's calculating. He can go ahead in parallel and continue to define and calculate additional operations. It also works in simulations. While he's doing a parallel simulation, and while it's simulating in the background, he can, at the same time in parallel, continue to work defining additional operations. And the third thing is that the user can start G-code generation, and while it's generating a G-code, he can in parallel continue to work defining additional operations. Now, parallel computing can be done in two different ways. It can be done locally on the user's computer while he's using the power of the multi-threading on multi-cores in the CPUs. And the other option is on a remote computer, where parallel computing can be executed on an external computer that exists on the network. Now, one of the major advantages in parallel computing is that it allows you within an operation to actually go directly and define your operation and send it to your parallel calculation outside and then continue immediately creating a new operation. Let's take a look now at how this works. Now, I'll start a new operation on this part by going into HSR, and I'll choose contour roughing, I'll choose my tool, and I'll choose the boundary that I want to work on, my passes, set up my offsets, set up my step down on the part itself, and then we'll do save and calculate. But instead of clicking on save and calculate, I'll click on the arrow next to it and click on save, parallel calculate, and exit. Now, while this is being calculated, I can start another operation of HSR and do, for example, rest roughing. Choose another tool, again, go to my passes, do whatever I have to do over here, and then, again, just do save, parallel calculate, and exit. And then this one now is being calculated. Start another operation, time in HSM, do, for example, constant Z, choose a tool, and continue on down as necessary. Again, I'll do save, parallel calculate, and exit. And now that one is being calculated. And I can keep on going down and keep on programming my next operation one after the other without stopping to wait for the finish of the calculation. Now, parallel computing is not something that can be done only within the operation itself, but from the outside as well. For example, I have now here a whole bunch of HSR and HSM operations that I've created. And as you note, these operations have not been calculated yet. To calculate this now, right-click and then calculate all. Now, when we would do this, the parts were sent only to one core in the computer, to one thread, and it will be calculated in line. The first one would finish calculating, and then the second one come up next, and then be calculated, while the rest of them are waiting for this to finish. Once this finishes calculating, then the next one will be calculated, and so on and so forth. Of course, this, however, in many cases, would take a long time. What we've done now is we've added the option over here of parallel operations, calculate all in parallel. When we calculate all in parallel, the program is actually taking all of the operations and sending them out to the multi-threadings that we have on our computers. And once that is done, it starts calculating the parts in parallel to each other at the same time. Let's take a look how this works. When I click on Calculate All in Parallel, what happens is this dialog window pops up. Now this allows me to choose whether I want to have it go on my own computer, on my local computer, and thereby using the multiple threads that I have on my computer itself, as shown over here, or I can use a network computer, and thereby having it being calculated on a different computer that's on my network. In this particular case, I'll be using local computer. Now, if I don't want this window to pop up again, all I have to do is click on Do Not Ask Again, which is what I'll do at this point. Now, the moment I click on OK, what's happening now is that all of these operations are now locked and being calculated at the same time. If I were to show you my Windows Task Manager, you can see that all my threads now are working parallel to each other with my maximum usage of my CPU. Now, if I were to go back into my operations and go back to parallel operations, you can see we have the option of show running parallel operations. Over here, you can see all the operations that are being calculated now at the same time. And as you can see also in my manager, some of them have already been finished calculating. That's because they're all running at the same time, and whichever is finished, it just finishes. Now, the program is smart enough to know that if there's an operation such as a REST roughing operation, which can't be calculated before the roughing operation, it will wait until this is finished, and then it'll start calculating the REST rough operation, but not beforehand. And as you can see now, this has been completely calculated. And as you can see, these are the operations that are left to be calculated as we go along. Now, while these are being calculated, I can continue and create another operation. I can go back into HSM, create a new operation, let's say REST machining, choose a tool, have my reference tool, have my passes, and again, I can do save, parallel, calculate, and exit. And this will just continue on at the bottom together with the other operations that I've done over here. Now, it should also be noted that when we previously calculated all of these operations in line and not in parallel, it took us 30 minutes to calculate all of these operations. But now that I used the parallel option, it took me a total of 9 minutes to calculate these operations. That's a great savings in time. Another option I have in parallel computing is that I can go into parallel operations and choose G-code all in parallel. When I do this, the G-code now is being created now parallel, and I can continue again if I want to create another operation here as well. I can say, again, I wanted to start now with an HSR operation and continue on computing at the same time. I don't have to wait until the G-code has been completed.